Right. Welcome, everyone, to another installment of our community meetings here. Great to see people, especially after the whipsaw time changes, which I apologize. Maybe put someone on the spot since we've had a lot of developments since meeting a couple months. I'm happy to talk a little bit about ICARM, but I think maybe to start off with, it'd be great if Adam could step in and guide us a little bit through what's been going on with the Mathlib initiative and highlight some of the things that they've done and things that they're aiming to do and things you can help with.
Yeah, sure. So I don't know, I assume everyone here is familiar roughly with what the Mathlib initiative is about. We got a quite large donation from Alex Gurko to essentially accelerate the development of, or scale up the size of Mathlib and the surrounding ecosystem. So we officially got started, I guess, September 1st. We have a few employees now. We have a website that's live. You can go to mathlib-initiative.org and see the current state of, well, the webpage. The key point, if you're interested in taking a look, is the roadmap, which already has an overview of what we expect to do in the first year. I guess I forgot to mention that this funding that we have so far is for 2 years. But we're already seeking additional funding. Right now, we're seeking additional funding to expand the scope for the first 2 years, but we'll also be looking to expand the timeline as well. Yeah, so some of the projects that we're working on now, we have Anna and Brian are now employed by the Mathlib initiative, as was announced on Zulip. I'm sure you all saw. So Brian is currently working on improving keyboard and in general the experience for Mathlib reviewers. Our goal here is to get Mathlib review time, at least Mathlib PR triage, down to about a week by the end of the first year. So that is going to be a big help in terms of getting contributions into Mathlib.
Are they working full time or?
Brian is working full time.
Yeah. Brian is working.
And
okay.
Yeah. Anna is currently almost full time, and they're working primarily on documentation at the moment. Yeah. So those are the two main things that have started going on. Improving documentation, improving PR reviews in Mathlib, at least the triage time for PRs. We also have some other objectives for the first couple of years. In particular, one of the big engineering challenges we're going to try to tackle is to develop some infrastructure to coordinate an ecosystem around Mathlib, where we can have somehow this dream that we've had for a while of Mathlib branded downstream repositories. The idea is to essentially not always rely on the Mathlib maintainers for every single mathematical contribution. We want to have external repositories that depend on Mathlib, that have some serious mathematical developments that are maintained by independent teams. But we'd like to have some infrastructure that coordinates things like when the lean toolchain is updated, we need to have, or any sort of refactoring happens in Mathlib, the analogous thing needs to be executed in downstream repositories, and we're hoping to develop some automation for such a workflow. And then the other main aspect of our plan for the first 2 years is to develop some tools to create training sets for AI and allow for the ability of AI agents to make direct contributions to lean projects. that has gotten started, but officially the roadmap for that particular part of our the timeline for that particular part of our roadmap doesn't officially start until 2026. But we'll have something out probably before that even. Yeah, I think that's about all the summary I have for now. I'm happy to answer any questions. Or
First, let me thank you for showing up and doing this, especially on short notice. Very, very,
oh,
very
I'm
helpful.
happy to.
Now, any questions for Adam?
Do you have like ideas of existing repos that could become those downstream Mathlib repositories that could be tried out? I mean, there's plenty, right? All of Reservoir is basically eligible, but do you have like specific ones in mind?
I don't know off the top of my head, to be honest with you. I don't think we've actually isolated any as of yet, because we haven't actually started on the engineering work to accomplish this. But once we start, we'll identify some repositories as kind of like a test bed for what we're going to do.
Okay. Yeah, I'd be happy to contribute my repositories if it's helpful.
Yeah, I figured that's why you're asking.
Yeah, that's why I'm asking.
That's certainly on the radar, but we haven't made any decisions at this point.
So super excited about the triage plans. I mean, Heather stressed to me that when she was a newcomer, the way she learned to how she became an expert was by responsive reviewer time, which of course was far more the norm in 2019, 2020, when the community was much smaller. So if we can get it back to that, that would be completely awesome.
Yeah, absolutely.
Other questions? If you could say maybe the top 3 things that a community member could do if they were interested in helping out in furthering the initiative and its roadmap, what would those 3 things be right now?
I think the easiest thing for the generic community member to do is to review pull requests in Mathlib. Somehow that's maybe the easiest thing to ask everyone to do. I think even Kim mentioned this on Zulip, maybe even yesterday, that they wanted to stress that you don't need to be a reviewer to review Mathlib PRs. Anyone can review, especially if there's a particular PR in an area that they're interested in. And those comments are welcome. I think that's probably the number 1 thing. That doesn't help the Mathlib initiative directly, but it just helps Mathlib in general. It helps, but indirectly it helps Mathlib initiative because the PR reviews, it helps with the PR reviews. In terms of other things that community members could do, if they somehow behind the scenes, we've been scouring the community Zulip and looking for kind of pain points in using the Mathlib library and in general Mathlib as a dependency. And we've been kind of collecting these comments behind the scenes. So if community members want to voice some sort of pain points they've had with Mathlib or the contribution process, or really anything related to Mathlib, we'll make a note of it and keep those comments in mind for the future. I'd say maybe those are the 2 main things. I don't know if I can come up with a third on the spot.
More reviewing.
More reviewing.
Yeah.
If there are issues that people encounter, make them known. Even, community members should feel free to ping Johan, Oliver, or myself on Zulip if something comes up.
Sorry, my wife got me plastic Mac because I'm too heavy to sit lifting it around. All right. Any other questions? Let's see, there are 2 things I want to put in your head for discussion. I'll talk a little bit about iCharm in the intermediate time so you can formulate your cleverest takes. First, that we heard about is AI contributions or AI formalization in general and how it interacts with the culture and the expectations of the community. What standards of code are. And we're getting pretty close to a point where this is going to be an important thing to reckon with, if we're not already there.
Yeah, so I think we've got like in the past 2 weeks, really, like, or maybe 3, we've got so many more like LLM slow posts on the list.
Oh yes.
Yeah.
Well, I'm not even necessarily talking about those. Those are problematic.
Yeah.
I'm talking about you're in a situation right now where these models can generate really, really good simulacra of truth, right? Even at the level of research mathematics. Like I often go to GPT-5 Pro and send it off to do something before I start thinking about it, just as a way to kind of, kick the tires. And then I have to stare at it for a while. One of the outcomes of this is I read it and I think, oh, well, I'll probably spend more time figuring out what the hell it's saying and checking the correctness of it than I would have thinking about myself and developing it. Right. And so that cycle where the AI is the creator and we're the reviewer, or we clean up after it, probably not what a lot of people signed up for when they think about advances in technology. It'd be really great also if you didn't have to clean up for it. Okay, so let me table that topic. We'll come back to it. I will give an update on the status of iCarm. So you may remember from last time, or maybe this is the first time you're hearing about it, but a new NSF institute was created in early September. I think the start date was September 1 at Carnegie Mellon, and it's the Institute for Computer-Aided Reasoning in Mathematics. And the idea behind this is to help bring the tools that have been developed in and around artificial reasoning, artificial intelligence, of which automated reasoning, symbolic reasoning, and formalization are very much in the mix for, to mathematicians more broadly. Right. This is not just formalization, but also tools that emerge from AI frameworks that can help answer questions in just regular natural language research level mathematics. And so it's been a lot of work, and it's going to be a lot more work to get this going. We don't have a web page yet, so we're behind on the Mathlib initiative on this one key point. But we have had some important developments. Let's see if I can share my screen. Window. This window. Can people see pretty well this webpage? Okay, great. So about a week ago, we had a workshop joint with Simon's Law for Mathematical Sciences Institute that focused on sort of setting the groundwork for formalization of PDEs. And we were very fortunate to have two of our key members of the community, Remy DeGen and Michael Rothgang, come and visit and interact with the mathematicians in residence at SL Math in Berkeley for the semester. Right now they have a pair of programs around PDEs going on, and they had a lot of interest from the participants in trying to explore potential collaboration development in Lean for these topics. And if you've hung around Zulip and listened to some of the conversations, you'll know that this is one of those things that often gets brought up as a topic that we'd really like to expand more on in Mathlib. This has been the case for a while, so it was very nice to see an event like this. I believe if you couldn't make it, the talks are recorded. You can check those out. I think you have to sign up for an account at Math, but at some point, if you're a mathematician, this is probably going to happen anyway. So that's one really great thing. Another thing that's happening with ICARM is that we'll be at the joint math meetings in DC in early January, and we'll have a tutorial on SAT solving in mathematics research. This is something I'm not an expert in, but we will have a wonderful expert and someone who's also very attuned to training and teaching in this way. And so that'll be, I think, a 1 or 2 hour tutorial there. And I can get the dates and more information soon for that. So that'll be interesting. We're currently working on our first workshop in-house at Carnegie Mellon in the space we will soon move into, and our first summer school. And so hopefully you will hear more about those and the details within the next month, if not sooner. Okay. And I will say we are still hiring. We've had some wonderful candidates apply already, better than I could have imagined. I don't think I can say anything precisely in terms of new developments at the moment, but hopefully soon I'll be able to do that. But we still have open positions, and if you're interested in this general area of the interactions between AI and research mathematics or applied, and you have skills that really fit with what we're trying to do, consider dropping an application in. And if you have questions, you can contact me or Jeremy about what ICARM is more generally and what this position would look like sort of as a day-to-day thing, how it could be structured. So that's my brief ICARM recap. Any questions?
Oh, yes, a question. Will you ever organize anything outside of the US, or is it all within the new building you'll have?
I think that's certainly a potential possibility. I would say that we want to break in the new building, and then hopefully there'll be more funding soon at a different location, but also in the US, where it will be expected of us to host events also. But, if I could ever organize something in Antarctica, which is probably a non sequitur if you didn't, show up before the recording started.
Yep.
That'd be pretty appealing.
Yeah, I'm sure. I'm just asking because I think it is going to be difficult for me and a few other people to come to the US in this time.
Yeah, I recognize that there's a lot of travel challenges, logistical challenges.
Yeah.
Historically, with coming to the US in general, and then these days. So we will keep those in mind as we plan stuff.
Mm-hmm.
Any other questions?
Actually, yeah, I guess a similar question. Since you're NSF funded, I assume you probably have NSF imposed restrictions on where and what you can use the money for, just in terms of being US centric. Is that true?
I mean, yeah. So in terms of things that you may have experienced, if you've interacted with NSF funding at events, you have things like the Fly America Act. You have to fly US carriers, but that can, US carriers have a large network of code shares that you can get around. You can satisfy this condition pretty easily. There's a little bit more focus these days on research security in the United States, both with the last administration and the current administration. Certainly at my institution, I see this being taken much more seriously. So that might impact. It might impact aspects. It might not. I really don't know from experience what that will look like, and I don't think any of the institutes really know at this point. Maybe they do. Maybe they have more experience because they've been operating the past year. That's another aspect of. But it's very much, and I think the NSF shares this opinion, is we want to do the best work possible. That will benefit American enterprise, American research, if we do that. Within the constraints that we have, that's what we're going to try and support the best work possible. Do I have one ask? Because this is something, may not be the best venue for this, but if anyone who's listening, useful libraries or frameworks, thinking things like Fund Search or OpenEvolve, if you know what these things are, OpenEvolve or IncaEvolve, that have been applied to produce interesting results in pure mathematics, natural language pure mathematics. Do you think that they need attention or at least greater exposure? Let me know. It'd be good to collect these resources and be able to show mathematicians them in one easy go. Then also coordinate feedback and any kind of distance with maintenance. We're very much in a situation where we have a whole bunch of new tools, and we just need people to go out there and try and start, groping around to figure out where these tools are the most effective. What kind of questions in different areas can we address with them? I think if we can figure that out, there's going to be some things that will really take off. We just don't know what exactly. And I guess in the vein of this particular meeting, we already see the Mathlib initiative doing a wonderful job of curating and maintaining documentation, very much along this line, that if there are useful resources for you, especially if you're just starting out or have just started out, it's fresh in your mind what things were valuable, mention those so that they can be featured, can be suggested. And then if there are resources to improve this space, those are the ones that get priority for improvements. Or if there's things missing, suggest those too. But we've seen a lot of that, I think, on Zulip Natural. Great to see. Any other questions? All right. So maybe, I've given you a little bit of time to marinate on the role of AI formalization, AI maybe more generally, in Mathlib and formalization more broadly. And I wonder if anyone has any thoughts about the situation they want to share.
I have a thought that is maybe not shared by a lot of people. I think we should allow the ability to have a completely black box proof of a proposition. And I envision some AI agent, or doesn't even have to be an AI agent, whatever program creates an expression, lean expression that has a that is the proof of a certain proposition. You pickle that expression in some database, and you're just able to access it as just a black box proof. So you don't care what the code looks like. You care just that it exists in that sense. That I think is one way of allowing pretty easily AI contributions where you don't care about whether the code that they produce is maintainable. All you care about is that the expression works. And because the expression type in Lean, as far as I can tell, is completely stable in Lean 4, I don't envision it changing, well, as far as I know. I assume that will work in the long term, and maintainability is not going to necessarily be an issue. That's just one thought I had.
Sounds like something that Mario probably would be interested in with the O-leans and stability. I think you talked about the ABI. Now, when you're talking about the black box, like, is a Pratt certificate something?
Sorry?
Is a Pratt certificate, or primality certificates, something that would fall in here, or you're thinking about something fancier?
It can be one of any sort of thing. Of course, if you have a primality certificate, then you need some sort of meta program inside of Lean to convert that into an actual proof in terms of a Lean expression of primality, right? And that's a piece of code that would have to be maintained. But if somehow you just literally store a pickled expression, you should be able to load it back in, completely memory mapped, and use it as a proof. Migrations? What do you mean?
Well, Mark asked, how do you ensure that the proof in your database still works when definitions change? And
well, it won't. Yeah.
right, but in regular database management, if I have a SQL database and I have columns and I wanted to make a new index or make a new view, I have a file that describes the transition between my previous database state and my new database state. So if we had such a database of underlying proofs, if there is some definition change, ideally you would have some sort of migration, some sort of diff file that you can go and apply to your black box proofs. So it'll become an even blacker box because there will be some original proof.
That's right.
Some diffs over time, but still something replayable.
I think that's certainly possible. I mean, there's a lot of research that, at least I heard about a couple of years ago, about proof repair. I don't know. I haven't really followed up on that, but I know proof repair was a hot topic at some point, and it seems to fall into the same sort of scope. But yeah, it's something to think about. I haven't really fully fleshed out this idea besides what I said. So it's good to hear some potential issues that need to be resolved.
Do you think that
Go ahead.
Morph or Harmonic are also interested in these things, because that way they wouldn't need to migrate Mathlib versions all the time?
I can't speak for Morph or Harmonic.
So if I very much the opinion that mathematics is a culture of human understanding. That the currency of mathematics is not like, here's a proof on a page of a result. It's the person reads the proof, and then what they get from that is deeper insight into the question. Ideally, it's written in such a way that you don't have to read the proof. You can read some of the context around the proof and understand better what new ideas go into it or what clever arguments have been developed. And so, do you imagine, like, where's the boundary of things that you would black box versus the things you would not black, or is there no such boundary?
I think, as far as I'm concerned, I completely agree with your assessment of what mathematics is about. But I think the boundary, well, in that sense, my opinion is that the boundary is these black box proofs are for things that you would never write down on paper. You know, like proof obligations when you're proving that some obvious thing is a functor between two categories, you know, or whatever other silly proof obligation that would take 30 lines to do in Lean, but it's completely mechanical and obvious, and you would never write it down on paper. These are the sorts of things that I envision. I don't necessarily envision, for example, having a black box proof of, you know, the strong prime number theorem, like Morph was able to accomplish. That should not be a black box proof. That should be a human understandable proof. But for kind of small things that we don't really care about, I think that's perfectly fine. And of course, maybe in the, you know, over time, maybe that boundary will expand as AI gets better, and maybe human mathematicians care less about certain things than they used to. I think it's perfectly valid for it to change as well.
You might say that anything, you know, Tauto or grind is already black boxing.
Yeah.
Think about the people in the Zulip channels that come and say, look, I really want to see the term for modus potens and, you know, the Barber paradox. Like, I want to see the explicit term that you've constructed. Don't show me a tactic. So it's just where that line is, I think, is different for different people.
Yeah. Yeah, that's true.
Let me ask a little more provocative question along this line. Have you seen any auto-formalized code is up to Mathlib standard anywhere in nature?
The only instances I've personally seen is when Copilot is able to fill in a very tiny proof with just the term, and usually it's more or less the correct term. But I have not seen an example where you have more than one tactic being applied.
Yeah, I agree with that sentiment. I was writing something down today, sort of mapping out an idea from my research in terms of triangulated categories and generation time, and using Claude because, you know, that's do now to get a draft before they start writing something. I gave a really nice inductive definition of generation and triangulated categories. Like, oh yeah, that's really nice. And we kept track of the number of cones and everything. And so I think you're right, in a very localized way, it's good. You know, it's one of these chains of steps where it can go off by epsilon at any given point, and then it does, but somehow can recover back. But process all the way around is really meandering and gratuitous.
So do we think it's like automatable to go from that, what we're currently getting from the AI, to something that is up to Mathlib standards? And it's just like that hasn't been incentivized yet?
I mean, I'd very much like to hope that if you provide the correct incentives, but it's like, you know, this is a question you can ask for applications of artificial intelligence in a lot of areas. It's just incentivized that it solves the problem, You can check that it solves the problem with a lot of these benchmarks. But the elegance, the value to human understanding, these kinds of things, I could, I don't know a whole lot, but I could imagine that if they were properly incentivized and the models were properly rewarded in some way for doing this, you would get better models. Humans get better value for the things that they do.
I think one thing I have never seen any of the AI projects try to attempt is to use linters and do some sort of reinforcement learning using linters to at least get proper code formatting.
It looks like the issue with linter specifically is that there are always a few tricks to disable the linters, and therefore the LLMs just learn to disable the linters by using this bug about hiding or velog. Like you could always start any proof with velog, then you get no unused viable error.
I think those LLMs are really like over optimizing for having a proof. And I think Adam is talking about LLMs that are really like helping the people. When I'm in VS Code and I have a Claude agent going, it's able to see my TypeScript warnings or errors in the ESLint that are emitted, as errors or just annotations. And it's able to recognize those in the file and says, oh, I just wrote something up, but I have a type error, or I have a formatting error. Let me reformat it, and it can do the code action itself. It's just a different type of fitness function that it's trying to go towards. I think the overall LLMs that try to like black box, you give it a statement, it gives you a proof. They're not in the code. They're not meant to interact with human written things. So I think we just have an impedance mismatch between like very fancy AIs and like what we're doing on a day-to-day basis.
Yeah, and so my claim is that looking at the output of linters is not a sufficient metric because linters are very easily trumped. I mean, maybe we should just fix the linters, right? But it's hard.
That's not a problem, because when you're training an AI with reinforcement learning, you have to create a reinforcement learning environment with some fitness function. And it's very trivial to not allow you to disable any linters.
No. But like, I don't mean disable with set option. I mean disable as in there is a bug in the linter that makes it not fire. And like a lot of linters have this. And the thing I mentioned with Veloc typically is we should fix it. But
the bug should be fixed.
Yeah, the bug should be fixed, but it's not clear to me that all bugs can actually be fixed. Some of them seem to be just like it would be too costly to do the right thing, because for a human.
What you're saying is the LLM, my TypeScript example, the way it would fix my type error or lint error is putting the comment "ignore lint error," right? You're just saying that it's doing it in a more roundabout way by invoking a tactic that makes it disappear.
Yeah, sure. Yeah, kind of.
But if you ask it, let's say I ask my agent and it what linter errors do I have on right now and how would you fix them? I think that would be a thing one could aim for first. Before it fixes, can your Claude or whatever explain what the issue is? If it can't explain it, then it probably can't act on it properly.
Yeah, that I agree with. I personally would like to have access to some LLM to try to do some formalization project from start to finish, and see what I get at the end. And currently, I haven't had the opportunity to do that. But like, has anybody tried to do this on a smaller scale? Like, what does that actually give you? And is it a waste of time as opposed to like doing it by hand?
God, I mean, my experiments have all been using something like, off-the-shelf foundation model, command line, maybe hooking it up to NeoVim in some way, so it can get some of the feedback created through errors and warnings in the editor. But it's very clear that these models, there needs to be at least some amount of post-training on them to try and get them to appreciate the subtleties of, and maybe not so much subtleties, but just sort of the quirks of writing good lean code. I mean, I haven't tried it in a while, but the simplest thing was that it could not figure out whether libraries existed or not, or modules existed or not. And so it could generate, a reasonable stub of something rather advanced, but then it would import something that is equally advanced, assume that it was there. Something that I was trying to generate some stuff today. There's a conjecture of Artin and Hochster about if you take the ring of two matrices over, say, the complex numbers, and then you look at their entries. So the entries are all variables, 1, 1, yada, yada, y, yada, yada. And you look at the ideal generated by entries of a commutator, y minus 1. You can ask, is this ideal radical or not? Meaning that if there's some element whose power is in the ideal, is the element in there. And so I asked it to just generate code for that. It screwed up the imports pretty well, but what it got was close enough to something that would work, that I went in and I could, with about 15 minutes of tweaking, get a statement that was correct out of it. And it was helpful because I don't really use the Matrix API very much. So it gave a pretty good window into a piece of it that I could get started from, like a handhold, and then climb the rest of the way up. But it was also things like, so to make things convenient, you made a def of this particular ring, and then it really should be in a breeve so that it could inherit all the instances from the underlying term itself. But things like that, where there's very, simple, specific patterns that are useful in writing lean code, is just nowhere. Like, I did it again with something else recently too, and the same problem persisted. It was like the number one issue fix in terms of the mode, right? Mode is the thing, and the maximal number of times something occurs. What was that?
Could I ask, do you think that it was writing it purely on syntactic recall of
Yes.
the other code it saw in your repository, or do you think that, again, I'm going to talk about TypeScript, that it's able to do semantic go to definition and I'll rephrase. Either it's pulling all of the code into its context window and it's doing some sort of syntactic and maybe semantic interpretation of it without any underlying language support. Or maybe it is using language support with go to definition. And so I don't I have a sense of how it works for TypeScript or other oftenly used languages. I don't know if it's smart enough to press F12 on a definition.
I don't think it had any kind of use of tools like that to try and navigate. It was just going off of what it had been trained on. Now, exactly what the representation, that knowledge is in there, how to sort it between syntax and thing. But in terms of actually being able to use tools to navigate, like we would, there was nothing like that involved. It was just straight plot at the command line, these kinds of things.
When I'm using VS Code Copilot or fixing some TypeScript thing, it'll say, "Oh, I'm reading the definition here. I see this declaration is here. I can, and I'll go check the file where this declaration comes from. And it says I do that either via grep or by the language support. So maybe a link here to have smarter code generation for Lean would be to understand how to get the plotter or whoever to use the language support that the FRO has built in.
Well, I mean, it's sort of my fault because I only use NeoVim. And so any kind of tooling around this interface is something that I just have to hope that someone builds out of the goodness of their heart. But if this is sort of the space that a company, I imagine, Cursor is, right? It's to bring capable models, but then interface them with the developer environment in a way that's actually productive for people. So maybe it's better to ask someone who's been using something like that for their experience, whether they find it helpful overall, or if they do, how helpful, right? And what are the limitations right now, and how could those maybe be improved for Lean in particular? Anyone a big Cursor user here?
I think their market share is starting to go down
Oh yeah.
because of other companies just being able to surpass faster.
I mean, Cloud Code is the winner, right?
I still like to see the code I write. Some of these tools don't even show you the code anymore.
Oh, is that right?
What?
If you go to Gemini, I was at a workshop with Gemini and DeepMind. If you go to Gemini AI Studio and you say like, make me a web app that like takes a photo of me and writes me a Dungeons and Dragons backstory with hit points, they'll spit that out for you in the web in like 2 minutes. So that's I'm trying to just like, I think we know that such tools exist, but I'm describing why IDEs like Cursor are losing market share. It's because people are now starting to be able to do code generation directly in the browser without having to have a separate client.
Mm-hmm.
And so why even have an IDE? Why even have your own editor if you can just like no code your way and just type into the browser and generate some things? Maybe
vibe coding future.
Should we have a live.leanlang with a model? I'm not probably the FRO might not want, but I don't know. FRO people, how good is Nova at Lean? And maybe that would get people asking these questions more if you didn't just have the little, VS Code web applet for Lean, but you even had a generator there.
So in the natural language realm, has anyone played around with this Helmos?
Sorry, with what? You were cut off.
Helmos. Hallmos. Hallmos. Helmos.
I haven't heard of it.
Okay, let me see if I can locate it. Okay, good. It's in my history. Added it to the chat. But it's a pedagogical tool for learning to write natural language math matrix. An LLM that will give you feedback. Your proof, then help guide you towards better structure, more correct, more idiomatic natural language mathematics. And know of it, and I've talked to people who have used it a little more extensively and played with it, and they find it very, very helpful, and something that it's useful enough that they actually suggest to their students in class as a additional aid for learning how to do these things. You taught an introduction to proofs class with lean, without lean, regardless, you know it's going to be a struggle for a lot of students to try and find the right level of detail, generality, fractions, and things. What actually is meaningful and what's not. And so, to me, that tells me that, I mean, it was something that was developed by academics with NSF funding, which means the amount of resources to create such a thing is not insane, where you need to go and be on the scale of, OpenAI or something. But it serves a purpose that's very much well suited to the goals of the mathematics. So if there are people who have the desire and the resources to create something like that, some vibe code natural language interface, lean, at least at the level of maybe some constrained portion of the library, it could, in theory, be pretty useful. Certainly will be amusing to see what comes out one way or the other. We're running up to the hour. Oh, here's something. Okay, cool. Invite you to click on that link and check it out. But we're running up on the hour, so maybe we should move to wrap it up a bit. Any last comments? Is there anything else? We can always take these things offline to do up too. Well, it was great to see everyone. Thanks again to Adam for showing up and telling us a bit about the Mathlib initiative and where it's at, where it's going. Next time, we'll promise to reschedule if I'm out well in advance. Again, I look forward to seeing you there or seeing you in Zulip where in time. Take care, everyone.
Bye-bye.
See you later.